here's where we left off. We have sweatshirts and t-shirts. We have our system of inequalities. We have our function, our objective function written down. We came up with all this information from that list of stuff off to the right. Now what we need to do is graph this thing. Yep, got to figure out where our origin is going to go, and we got to come up with a scale. So where's our origin going to go? Lower left, and that is going to take care of these two inequalities right here. By putting the origin in the lower left-hand corner, I know that we have to have positive values. So I'm going to very carefully, I'm actually using a ruler this time to draw my axes in here because I want to be very accurate. And we all know how well I draw straight lines. Okay, so that takes care of these two inequalities right here. Now for the other three. The temptation is always to put them in slope-intercept form. I've been trying to get you guys away from doing that. They're in almost standard form right now. It's easy to graph intercepts when they're in that form. And if you're graphing intercepts, you can easily come up with scale. So let's take a look at, actually before I do that, based on the way my function is written, my objective function, what do you want to put on the x-axis? It doesn't matter. You can put sweatshirts or t-shirts. But normally in function notation, we'd write x comma y for our ordered pairs. So we've kind of put s in the x position. So I'm going to put s sweatshirts on my x-axis. So this will be number of sweatshirts. And then t-shirts on the y-axis. Now, of course, we're going to have to come up with a scale, and we can see that we're dealing with some big numbers here, so we know we're going to have some sort of scale that's not by ones. What I want you to do is come up with the x-axis scale first. So the s-axis, look at each inequality and figure out what that intercept is going to be. We have an s-intercept. If t is 0, then this term disappears, and I'm left with 30s equals 1200. So the s-intercept in this case would be what? 40. 1200 divided by 30 is the same as 120 divided by 3, which is 40. So we know we got to make it to 40 at least. Do the same thing for the next one. When t is 0, s would be 600 divided by 20, which is the same as 60 divided by 2, which is 30. So I have a 40 for this one and a 30 for this one for my s-intercepts. And on the last one, I would have an s-intercept of what? 50. Okay, so all of my intercepts are 30, 40, 50 on my s-axis. The biggest number was 50, so I got to make it to 50 here. By 5s would work, so let's do that. And I'm going to go ahead and label. I'm going to put 10, and then 20, 30, 40, 50. I'm not going to put any points on there just yet, but now I know my scale because I'm trying to figure this out using intercepts. So now we'll do the same process for t. When s is 0, this term disappears, and I'm left with what? t is 120, so we have a t-intercept of 120. On the next one, when s is 0, we get 4t equals 600. That would give us a t-intercept of 150. And then finally, the last one, t-intercept would be 50. So the biggest number we got there was 150. So I got to make it to 150. We have 14 lines here. By 10 would get me to 140. And then I'd have to kind of go up a little bit higher to get to 150. Okay? Now normally that's not cool. The y-intercepts need to be, your intercepts all need to be on the graph. But we are not interested in intercepts here. We're interested in the feasible region. The feasible region will be somewhere in here. It's not going to incorporate that y-intercept there. But we can't just put down 150 and put a dot. We're going to have to sort of backtrack. We'll assume it's here, and then we'll backtrack so that we wind up back on the graph so that we can put a dot somewhere on the grid and then graph from there. Okay? So that's sort of the process. Something else you could do is just change the scale and make it not by 10s anymore. You could make it by 20s, and then you would be on the graph. It's going to make it a little bit tougher though because you want your graph to be as spread out as possible so that you can more easily pick out those intersection points. So we are going to leave 10 as our scale here. And then I'll label that. Okay, we're all set to graph now. So I'm just going to start graphing using the top one. We have 30s plus 10t less than or equal to 1200. Graphing using intercepts. When t is 0, this term disappears. S is 40. So I'm going to mark when t is 0, S is 40, right there. When S is 0, in the same inequality, t is 120. So I go to 120 here and mark it. Very, very carefully draw in that line. And which way do we shade that line? So it says less than right here. We're not in slope-intercept form, but that's okay. We can imagine putting it in slope-intercept form. We're going to wind up dividing by a positive, which is going to keep that inequality less than, so we're going to shade below. All right, the first one's taken care of. Second one, 20s plus 4t less than or equal to 600. Do the same thing. We find our s-intercept by making t 0, and we get what? 30. So when t is 0, s is 30. And now my t-intercept is 150, which we know is off the graph. So I know it's up here somewhere, but I am not going to guess where that is. Can't do that because that'll give me an inaccurate line. So what I need to do actually is, unfortunately, put this thing in slope-intercept form. So off to the side here, I will solve for t. I'm solving for t because t is my y variable here. T is on the y-axis. I want to solve for y normally, so I'm solving for t. Subtract 20s from both sides, and I have 4t is less than or equal to negative 20s plus 600. Divide everything by 4, and you get t is less than or equal to negative 5s plus 150. Slope-intercept form allows me now to use that slope and that y-intercept to get back onto my graph. So I know I'm living up here right now at 0, 150. So now what I want to do is figure out how to get back on my graph. The slope is negative 5, right? So I'm going to put something on here that's directly in the way of everything that I want to do, so I'm going to have to erase it here in a second. But this is just like an aside. A little thought process here. My slope is negative 5, right? Which is the same as negative 5 over 1. Agreed? Well, isn't that the same as negative 10 over 2? Yeah. And that's the same as negative 15 over 3, right? Well, my scale for my y-axis, or my x-axis, is by 5s. So wouldn't that be the same as negative 25 over 5? My scale on my y-axis, though, is by 10s. And I'm sitting at 25 right now. So if I double that again, wouldn't that be the same as negative 50 over 10? Do you agree? Okay, so the slope is the slope, but you can change the slope. You don't have to use the number that you see. You can make it match your graph. My graph is going by 10s here and by 5s here, so it makes sense for me to use this as my slope instead. So now here I am all the way up here at 150. I can get back on the graph by going down 50 and then right 10. Now I have an actual dot that definitely exists right there on my graph. I'm graphing using red, so I'm going to change this little purple dot to a red dot. And I have my s-intercept down here. That's all I need. Now I can graph it. And which way are we shading this one? What's that? Down. So I draw little arrows down. And now I can see that from these two guys right here and the two that I just graphed, right now I'm confined to this little region here. Okay? There are 4 vertices there right now. I'm not done though. I still have to graph this one. This one is very easy to graph using intercepts. We have an S-intercept of 50, which is all the way over here, and a T-intercept of 50 as well, which is right there. We draw that one in there. Again, extremely accurately. And which way are we shading that one? Above. So the region then, that is my shaded region, is right here. That's the feasible region. And now let me get rid of this little experiment we did here with the slope. Don't need that anymore. There's my feasible region. What we do now is we find the vertices. So let me mark those. I have a vertex right here. I have another one right here, which incidentally we know those because those were intercepts when we graphed them. I have another one right here. It looks like it might be directly on that grid line based on the way I drew it, but I don't know for sure. And we have another one right here, and based on the way I drew it, that is definitely not on that grid line. So we have a problem. We cannot guess what our ordered pairs are. And these did not fall exactly on grid lines for us. So that means that we're going to have to solve those two inequalities that involve those two lines using either elimination or substitution. So we can find those exact ordered pairs where those things cross. Okay? So there's more work to do on this problem before we can call it quits. First, let me get my table of values on here. I have my S comma T ordered pairs. I have my function 20S plus 6T. And right now I have 2 ordered pairs out of my 4 that I know for sure. I have this one, which is 0 comma 50. And I have this one, which was 0 comma 120. I have 2 more that I have to find using algebra. So we need to find, I wrote that one down, I wrote that one down. Let's find this one. I'm just working my way clockwise around. So let me change colors here so we can actually see. Okay. Now the question is, what is this intersection point? So what I'm going to do is I'm going to take the line here and the line here, then look back and figure out which equations gave me those 2 lines, and then I'm going to use either substitution or elimination to figure out where they intersect. Okay? So this one right here was my 150 one. That's this guy. So I'm going to use, actually let me use purple so we can tell the difference so I can erase later. I'm going to use T equals negative 5S plus 150. We're finding the intersection point. We don't need to worry about the inequality anymore. It turns into an equal sign while we do this. The other one was the one where we had a t-intercept of 120. Which inequality was that one? A t-intercept of 120 was given to me by this one right here. So the other equation we're going to use then is going to be 30s plus 10t equals 1200. Which method would you like to use to solve this one? It's set up right now for substitution. So let's use substitution. We take the t and we plug it in right there. 30s plus 10 times negative 5s plus 150 equals 1200. Distribute 30s minus 50s plus 1500 equals 1200. Combine like terms, negative 20s plus 1500 equals 1200. Now I subtract 1500 from both sides, and I get negative 20s equals negative 300. I divide both sides by negative 20, and I get s equals positive 15. So now that I know that s is positive 15, I can write that here. And I got to find the t value that goes along with that. Take 15, I can plug it back into this equation right here. 15 times negative 5 is negative 75. Negative 75 plus 150 is 75. So 15 comma 75 is one of my ordered pairs. And it does, on the graph, look like 15 comma 75. It looks actually like I could have called it 15 comma 75, but I didn't know for sure. That's why we did this algebra, to make sure. This one right here, definitely no idea what that one is. So we definitely need to do algebra for that one as well. This ordered pair comes from this line, which was my bottom inequality, and it comes from the 150 y-intercept line as well. So for that one, we're going to use this inequality, t equals negative 5s plus 150. And this inequality, s plus t, is equal to 50. Substitution again. So we have s plus, parentheses, negative 5s plus 150 equals 50. So that becomes negative 4s plus 150 equals 50. Subtract 150 from both sides. Negative 4s equals negative 100. So therefore s equals positive 25. If I look at my graph, it does look like I could be at 25. So it was my screw up, my bad graphing, that led me astray and made me have to do this algebra. But now I know for sure that it actually is 25. And now I take that 25 and I substitute it back in up here. 25 plus t equals 50, so therefore t has to be 25. So 25 comma 25 is my other ordered pair. All the heavy lifting is done. From here on out, it's a piece of cake, right? Okay, so we just substitute in numbers. We have 20s plus 6t. That is our function that we came up with. That's our profit function that we made up because we have a profit of $6 for the t-shirts and a profit of $20 for the sweatshirts. And we want to maximize our profit. So we're going to substitute things in here, get some answers, and figure out which one of these is our maximum value. All right, so we have 20 times 0 plus 6 times 50. Well, 6 times 50 is 300. So in that case, we'd make $300. Then we have 20 times 0 again, plus 6 times 120. What's 6 times 120? 720. So in this case, we'd make $720. Looks a lot better to me than the other one. Now we have 20 times 15 plus 6 times 75. What do we get? 750? 20 times 15 is 300. If I had 6 quarters, I'd have $1.50, so 150. 300 plus 150? No, sorry, that's quarters. I need 3 times that amount. Sorry, I screwed that up bad. It's 750. And the last one, 25 and 25. 20 times 25 plus 6 times 25. Now it is 6 quarters, that is 150. What do we get? 650. Okay, so to answer the question then, how many t-shirts and how many sweatshirts should you make to maximize your profit? Yeah, that $750 right there is the maximum profit. It asked me how much is the maximum profit? Max profit equals $750. And that's with 15 what? Sweatshirts and 75 t-shirts. There's your answer after all that work. But that makes the most amount of money for you, and that's the whole point of this section. If you were a company, you want to make the most amount of money possible. So therefore, this is what you would make. 15 sweatshirts, 75 t-shirts. So now, even though the t-shirt is, or the sweatshirt is cooler, when you go to buy that thing, it's sold out, so you're forced to buy the t-shirt now. And that is what I was talking about last time, where companies will make certain numbers of certain things because that is what makes them the most money. So when they sell out, and that's all there is to it. That's why you're then forced into buying the other thing. Okay, brand new problem. If you need to take a break or something and cry a little bit, that's okay. You can do that. But then come right back and do this problem. A company makes audio and video players. In one shift, the production ability and cost per unit are shown in the table. So rather than a shirt with a price tag on it, this time we just have a table. The company requires at least 2,000 units to be made per shift. So if you are a worker, you have to make sure that at least 2,000 things wind up being completed while you're there. How many of each type of player should the company make per shift to minimize their cost of production? So minimize cost. That is going to be our objective function. The company requires at least 2,000 units made per shift. That's going to be one of our constraints. The rest of our constraints show up here. Okay? So, we need two variables here. A and B. A and V, audio and video players. Okay, sounds good. The two things that we are changing are the number of audio players and number of video players. Audio, A. Video, V. The hard part of the problem is now over. The rest is easy. No? No. Oh, okay. All right, well, let's start coming up with some constraints now. The company requires at least 2,000 units made per shift. We could probably start there. Good. Almost in unison even. Nice job. All right, so that takes care of that information. Now we have a bunch of information in a table here. It says the table shows the production ability and cost per unit. So production ability is here. For audio players, I can make a minimum of 600 in one shift, but I can only make a maximum of 1,500 in one shift. So how could I write that as a set of inequalities? Mm-hmm. So A has to be sandwiched between 600 and 1,500. I actually have two inequalities there. A is greater than or equal to 600. A is less than or equal to 1,500. Now likewise for the video players, what will I have? Good. Okay, so now we have how many total constraints? There are 5. Is there anything else that I can put on there? The cost, but the cost is what we're trying to minimize. The cost is actually going into our objective function. We've used all the other information. We used all of that. We used that. We just have cost remaining. So my objective function is going to be f of my two variables, a comma v, equals the cost of the audio players, which is 55, so it'll be 55A plus $95 per video player. There's your system of inequalities and your objective function. Of course, we can't have A or V be negative, but that's taken care of by these two right here, so I don't have to list the trivial ones of 0. Okay? If I separate these out, what this says is A is greater than or equal to 600, A is less than or equal to 1500, V is greater than or equal to 800, V is less than or equal to 1700. So before we come up with the scale, we should figure out which one goes on which axis. Audio we'll put on X, okay? And this is video. Number of audio units, number of video units. Our axes, we can put in the lower left-hand corner. We know we can't have any negative units. We know we're not even going to be below 600 or 800, but that's okay. We can put 0, 0 on our grid. Okay. We got to come up with what now? Need a scale. Let's take care of the scale for audio. We know for sure for audio we got to make it all the way to 1500. If we look at this one right here, we have an audio intercept of 2000. So it's probably going to make sense to make it all the way to 2000 for our audio axis. We have 14 lines. Come up with a good scale. 200s? Okay. So I'll put by 200 over here. And then I'm going to mark 2, 4, 6, 8. Here's 1,000. 2, 4, 6, 8. Here's 2,000. We need to come up with a good scale for video as well. I know I have to be between 8 and 1700 anyway, but if you look, we're also going to have a video intercept on this one of 2000. So how about a scale of 200s on that one as well? And I'll mark that. Here's 1,000. Here's 2,000. Okay, the next thing to do is to put your constraints on the graph. We have the scale, we have our labels, we're ready to go. So the first thing I'm going to do is graph these guys because they're easy. So let's go ahead and do that. Check out those totally straight freehand lines. And if I mark the constraints, then I'm restricted to within this region right here. So now I just got to graph this guy. I can graph that using intercepts. I have a V-intercept of 2,000. I have an A-intercept of 2,000. So now I'll just go ahead and draw that line in there. So now I have all of my constraints in here. I know from before that I'm restricted to this little region right here. When I draw this line in, the inequality says greater than, so that would be shaded above, which means that this region is my feasible region here. So I'm going to have several ordered pairs that I got to find. Let me go ahead and mark those on here. I have an intersection point right there, 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 and there. There's actually 5 ordered pairs here that we have to deal with. So I can set up my table, A comma V, set up my function, 55A plus 95V. draw my table. The tricky part here is figuring out if these ordered pairs actually are where I think they are. For these vertical lines and horizontal lines crossing, we know exactly what that intersection point is because we graphed it. This is 600 here, comma, 1700 there. So I have 600, comma, 1700 for sure. Don't got to worry about doing algebra on that one. So I started right there. This one's taken care of. Moving clockwise around, I know this one as well because I graphed it. That is 1500, comma, 1700. So I label that one. All right, and that ordered pair is done. Moving around clockwise, I go to here. Again, I know that one already. That is, again, 1500, but comma, 800 this time. And that one's done. Now I have these two. It looks like it's probably going to be something, comma, 800 for sure. And it kind of looks like it's going to be 1200, comma, 800. But I'm not 100% sure. So I can't call it 1200, 800. But I am going to take that 800 for V and plug it into one of my inequalities up here. If I plug 800 in right there, I have A plus 800 equals 2000, which gives me 1200. So it actually is 1200, comma, 800. And that one's done. One more. I know the x coordinate here. The A coordinate is going to be 600, comma, just to make sure I can take that 600 and plug it in to the same inequality. 600 plus what gives me 2000? 1400. So that's going to be a 1400 there. So even though we had to do a little bit of algebra there, it wasn't as intense as the other ones because we already knew one of those coordinates because of the fact that we graphed vertical lines and horizontal lines. So those vertical and horizontal lines sometimes can be very helpful. Now we have all the ordered pairs that we need. What do we do? Evaluate them, yeah. So we're going to substitute stuff in. 55. By the way, make sure that you are substituting into the correct variable. We are writing these A, comma, V. The x coordinate A, comma, the y coordinate V. 600, comma, 1700. So we're substituting those into the correct ones. I see a lot of people make mistakes on these problems by substituting the numbers into the wrong variable. So just make double sure that you're checking or that you're putting those in the right variables. So we have 55 times 600 plus 95 times 1700. Obviously, you're going to want to use a calculator for some of these. I'm just going to continue writing these in. We have 55 times 1500 plus 95 times 1700, and so on. So that's the completed table. Do we have some answers for 600, comma, 1700? 194500. And the next one, 1500, comma, 1700? 244,000. And the next one? 158,500. And the next one? 142,000. And the last one? $166,000. All right, so now all of our values are calculated. We go back to the problem, and it says, how many of each type of player should the company make per shift to minimize cost? So minimize means we're looking for the smallest amount. That rules that one out. 142,000, that's your minimum value right there. So the minimum cost is $142,000. And they will get $142,000 in cost if they make $1,200 audio and 800 video players. So again, that is why companies make certain numbers of certain products, even though they're very similar. In this case, 1,200 audio, 800 video players. Anything more than that, any numbers that are different than that, and they will cost them more money to produce that.